Hello everyone. With half-life questions, the first thing you got to do is just kind of write down what you have, sorting out the times between the half-life time and the time that the sample has been observed. Make sure you get them in the right spots, and then sort down whether you're given the original amount or whether you're given the final amount, and then use the equation or equations that I gave you in the lesson. The equation for half-life is in your formula sheet as well. It's in the middle column at the very bottom under atomic physics. You can see they give you the half-life formula, but they don't give you the little n formula. If you want, you could jot that down on your formula sheet or commit it to memory, which is probably ideal since you're going to have to do that for the diploma exam anyway. The other thing I'm going to caution you about is to make sure that you have everything in the same units. You can use time in seconds as long as the half-life and the time observed is in seconds. You can use days. Again, they just both have to be in the same units. And same with the activity, or same with the initial and final amounts. They need to be in the same unit systems as well. So whether you use the units of becquerels like I have, or kilograms, or even if you use it as some percentage, which you'll see in an example 3, it doesn't matter. If you've taken Pure Math 30, you'd actually study this in your exponents and logs unit, and you do lots of half-life questions in there. We're just continuing on with the same type of problem. So example 1, polonium-210 has a half-life of 138 days. So that's the first thing I'm going to jot down, is my half-life time, 138 days. If the original activity, so that's my initial amount, is 4,800 becquerels, what would be the activity? So what they want is to find out the final activity after 690 days. So you can start with the half-life formula. N equals N initial 1/2 to the little n. That's equation 1. We're going to solve for big N in this question, but we know the initial amount. We just have to figure out little n using the second equation. That's going to be time over T1/2. So if I can figure that out quickly, 690 days over 138 days, that will tell me the number of half-life periods. So 690 divided by 138 is telling me it's going to go through 5 half-lives. So this should be, you could actually kind of estimate this. You could just take your 4,800, multiply it by 0.5, by 0.5, 0.5, 0.5, 0.5, basically 5 times to get this number, or plug it into the formula. N equals 4,800 times 1/2 to the power 5. Make sure you punch this in on your calculator correctly. 4,800, and I bracket the 1/2, and I raise to the power 5. So I use that hat symbol on my calculator and put in a 5. You will see opportunities or questions that may have you raising to a fraction or may have you raising to a decimal. Then you may want to bracket what you're raising it to so that you are making sure that the calculator understands that it's not just the first number after the hat symbol, it's the whole expression. If this was 5/2, I would put that 5/2 in brackets. So it's 4,800 times 1/2 to the power 5. I should get an answer here of basically a fairly small activity now, 150 becquerels. And one of the things I mentioned in the notes, activity decreases over time. Here's an example that proves that. We started off with a fairly high activity, 4,800 decays a second. After 5 half-lives, it's down to 150 decays per second. Always keep your units. Time units are the same. Activity units are the same.